This is lesson 1 in the first year 13 topic of side B. This is unit 6.1 capacitance. This lesson is about capacitors. This will be something completely new to you, so make sure you are ready to take some notes. So first up, what is a capacitor? Well, a capacitor is this thing here. It is essentially just two metal plates. And this is a pretty simple circuit here where we've just got a cell, a battery, and it's pushing electrons around the circuit. And the electrons build up on one of the metal plates because the electrons are being pushed onto this metal plate. And then there's a gap of air between them. Sometimes there might be something else, like a bit of plastic in between. But basically in between is some insulator. And then the electrons are being taken off of this other metal plate. So electrons are being added to this metal plate on this side. And the electrons are being taken away from this metal plate. So what you get is a negative charge built up on this plate and a positive charge built up on this plate. This stores electrical energy, and these can in fact store lots and lots of electrical energy and then release that electrical energy in a very sudden burst, very high power. So these can be really, really useful in many circuits, and we'll have a look at what they are in a moment. So this is a look at capacitors within a circuit. This is my cell, this is my capacitor here. And what you can see is this side here, side B of the capacitor, gets a negative charge. The side of the capacitor attached to the negative end, the negative terminal, gets negatively charged. The side of the capacitor that is connected to the positive terminal gets a positive charge. It gets a positive charge of plus Q, and this receives a negative charge of minus Q. This gains electrons, this loses. And in between we have an insulator, and so far we're just going to look at air. This is the symbol for a capacitor in a circuit diagram if you're going to draw a circuit diagram. Now, some key facts about capacitors are going to show up on the screen now. Feel free to pause the video and take some notes. So pause the video now and take some notes of these. The amount of charge that can be stored on a capacitor, that plus Q and that minus Q, the amount of charge that we can store on it depends on two things. It depends on the potential difference across my capacitor. So here's my capacitor, the two plates, the top plate and the bottom plate, the positive charged plate and the negatively charged plate. The amount of charge I get depends on the potential difference. If I have more potential difference, I'm basically able to push more charge onto the bottom plate and pull more charge off the bottom of the top plate. So push more charge onto this plate, pull more charge off of this plate. The bigger the potential difference, the more charge I store. And it also depends on something called the capacitance of a capacitor. The capacitance is a number. Different capacitors will have different values for their capacitance. The capacitance can be changed by, for example, having a bigger area of the metal sheet. So the bigger the area of your metal sheet, the bigger your capacitance is. It's able to store more charge. You can also change it in other ways by changing distance between the plates and inserting different objects inside in the gap between the plates. But we won't look at that for now. We'll come to that later. But the amount of charge you store depends on the potential difference and the capacitance. The standard unit for capacitance is named the farad. It's named after Michael Faraday. It's a capital F, named after a very successful, very famous physicist called Michael Faraday. Now, 1 farad is a very, very, very large capacitance. That, if anything has got a capacitance of 1 farad, it's huge. Most capacitors that we'll look at will be microfarads, so it'll be times 10 to the minus 6. That's something worth bearing in mind. A few exam definitions that you must learn are capacitance. It's the amount of charge transferred per unit potential difference. The farad is defined as a capacitance of 1 farad is when a potential difference of 1 volt across the capacitor leads to a charge of 1 coulomb. Make sure you have those in your notes. Building on from the definition for capacitance, we can get an equation for it. If capacitance is defined as the amount of charge transferred per unit potential difference, then we can get an equation for capacitance, C, capacitance equals Q over V, charge stored divided by potential difference. Q is the amount of charge stored, measured in coulombs. C is the capacitance, measured in farads. And V is the potential difference, measured in volts. And we could rearrange this equation to get Q equals C times V, charge equals capacitance times voltage, or potential difference, and potential difference equals charge stored divided by capacitance. Let's try this in an example now. So here we've got a camera, and the flash has a 185 microfarad capacitor connected to two AA batteries. And the two AA batteries together cause 3.0 volts of potential difference across the capacitor. Calculate how much charge can be stored in this capacitor. So I'm going to write down the things I know from the question. I know the capacitance is 185 times 10 to the minus 6. Remember I said capacitors are often given the units of microfarads. V, the potential difference, is 3.0 volts. The equation we're going to use, we want to find Q, so it's Q equals C times V. Q equals the capacitance value times the voltage value, and I get a value for the charge stored as being 5.6 times 10 to the minus 4 coulombs. Now we said that capacitors store electrical energy, and they're very commonly used in flashes. Flashes require a very sudden burst of electricity, and you want a lot of power. You want a lot of power in a short amount of time. You want a lot of charge, a lot of current in a short period. And you can use a capacitor to achieve that. What you do is you attach your capacitor to a circuit, and your capacitor will then charge up. It will get charged up, and it will store charge. You can then flip the switch so that now the capacitor is in series with the bulb, and all that's connected together is the capacitor and the bulb. A capacitor will get rid of its charge very quickly. It will discharge very, very quickly, much more quickly than a battery will. And so it will make your bulb flash. Your bulb won't be on for a very long period of time, but it will be a very bright, short burst flash. And that's why they're used in flashes. They're very, very useful for that. Can you think of how you might be able to discharge a capacitor more slowly? How could you make the current take a long time to go around? One way you could do it is you could insert a resistor into your circuit. If you inserted a resistor here, it would take a longer time for the charge to come off of your capacitor and go around the circuit. And this is something we're going to be looking at in 3 lessons time, and we'll be spending a couple of lessons on it because it can be quite complicated. Make sure you complete the other physics questions now on capacitors. There's only 2 to do.